I can do it. Good afternoon. I'm excited to be here and talk to you about some lessons I've learned from ranking medicinal plants. And this is intended originally as an educational workshop for those of you who are also teachers. What I've learned about an activity I've done with 5 of my classes that you could also do. But then over the last few days, I've realized that it's also a call to everyone, educator or not, to get you to rank some plants as well. So before I can talk about these lessons, need to discuss 2 big things. First, where I've been doing this teaching, this activity, and the tool I have been using. And I've thrown in plant pictures throughout because I like them. And I figured that you will also. So I have a few bullet points. I have some plant photos. First, where I've been working is Southwestern Oklahoma State University for the last 6 years, and the 4 years before that at Glenville State College. I realized that I think that I'm an active, ongoing part of SEB, and that my years of attending regularly, which I was here 5 out of 6 years in a row, have been 8 years not. During that time, I had 2 kids, changed jobs, and got tenure. Among other things, I did not stop looking at prairie turnips. For those of you who know me from before that, I've gone back to my prairie plots the last 3 years, and the population has crashed, and I don't know why. And we'll talk about that some other time. But I teach now at Southwestern Oklahoma State University, which is not actually in Southwestern Oklahoma in the center of the U.S. It's in central Oklahoma. This is Southwestern Oklahoma, Wichita Mountains, but no, it doesn't look like this. But he did a primarily undergraduate university in a biology program. My job involves teaching ecology and general biology. No ethnobotany. My students in biology are required to take a plant class, and they're required to take a field class. And as it happens, plant taxonomy, which I do teach, despite not being a plant taxonomist, counts for both. So the pre-med students who are thinking ahead save up to take this class that they are dreading. Even though they've had me for other classes, by and large they like me enough to admit the first day of class that they are dreading my class. Most of them like it, and many of them will admit their surprise at liking plant taxonomy. And some like it an awful lot. But one of the things that I am trying to do while teaching this class, as well as all of my other classes, is engaging students who, in many cases, are single-mindedly focused on applications to professional schools in real science, human science, and plant science. And I have been supported here by the Oklahoma Embry program, which is an NIH program to develop skills in future biomedical scientists in general. So I'm trying to figure out ways to get students involved in real science, even though they want to go into medical school. And that's the background from the school side. The background from the tool side is that many years ago, 16, as an enthusiastic undergraduate, I was asked by my advisor to work with the United Plant Savers you've heard about them today, to help make a quantitative tool to rank plants based on their threat of being over-harvested in the wild. And they were already known for this list, but the criteria were not clear, and they had no way to delist them. If we conserve them properly, how are we going to delist them? There was a need for a quantitative tool. Side note to grad students, beware advisors bearing side projects. I'm talking about my side project 16 years later. The other side project from my dissertation involved writing a book for a Crow woman. I spent all of my summers helping edit her plant use book. So be aware of advisors bearing side projects. I was enthusiastic. I said, sure, I'm doing multivariate statistics. We'll just take population size, multiply it by harvest impact, divide by some correlate of plant part used, and we will have a number, and it will be a great number. And then it took me longer than it should have to realize that even for the best studied species, I worked in the lab that studies echinacea. Even for the best studied species, these factors are unknown. So we had to come up with something else. About the same time, the seafood mini guides, ranking of which seafood you should eat based on environmental factors, were becoming widespread. And so I called up the creators of the seafood mini guide and figured out, how did you guys rank your seafood? And they told us that there were lots of factors, and no, they didn't know population sizes. They didn't have the numbers any more than I did. And so there were just 5 areas they assessed these based on. I was in a conservation biology class where we talked about Rabinowitz's 7 forms of rarity, where plants, animals, other organisms are deemed to be rare, super rare, or super, super rare, based on where they fall on 3 parameters. And we came up with, this is myself and a bunch of other people, 5 areas where that affects wild harvested plants. Their life history traits, the effect of harvest on individuals, how they are harvested, how quickly they regrow, the population size to begin with, the vulnerability of their habitat, and the demand. And we made a tool with asked questions about these things and comes up with a quantitative score, which is pretty cool. And then I had the great insight to link my class and this tool and to force students to score plants. And I think it's a great activity. You can do it as well. First, it is authentic. The students are combining information in a way that has not been combined before. This is real science that is being then used. It requires a lot of analysis, data searching, other skills, just the value of information. One student, afterwards, when I asked what she learned, she said, I learned that there's a lot of bad information on the internet. And I was like, it took you 18 years to figure that out? But I'm glad I helped. So requires transferable skills. That will be good, useful in my plant taxonomy class, but unlike learning the traits of families, they also do in my plant taxonomy class. This is directly transferable. And we are required to do a service learning project. It is great to have, say, this is data that is being used by a conservation organization for real conservation. And besides, medicinal plants are fascinating. Most of my students didn't realize that medicinal plants existed prior to this class, so that in itself was great. And then I came up with the idea of making them make a poster, a class poster, and present it at mostly local conferences. I've sent them to national conferences with this. So they all admit to working harder when they have to make a poster. Well, actually, one was offended that I asked that. I would work very hard anyway. The rest admit they worked hard. Here's a few scores of plants. These are prairie plants. I wanted to point out that not all medicinal plants are woodland natives. So plants, students scored. The higher the score, the more vulnerable the plant is. We had to score some that are not vulnerable to make sure the tool is working. And then here are their posters. The big blank spot in the middle was so that people could walk by and pull out a copy of the tool themselves and take it home and rank plants. This was presented at Ethnobiology in 2012. This was presented at the Oklahoma Research Day 2014. This presented at the Oklahoma National Researchers Conference 2016. And these last two I did not even edit. I just pushed from my desk to the print shop, which is kind of crazy. It's a frustrating activity. It's a lot of work to score a plant, and there are a lot of dead ends. This isn't me pulling my hair out in the wind in my field site. It is really hard to grade a student who is coming up with new information. Assessment is difficult. They also procrastinate, as does everyone, but it's worse when they're doing a group project poster together. And I want the posters to be better than they are. But it is worthwhile, I think. And there's a lot more to do. So you too can score medicinal plants. Ask me how. And thank you to my advisor who got me involved, SWOSU Biology, OK Embry, United Plant Savers, 76 great students and 3 not so great.